Maths Aspirants is a community of mathematics students, research scholars, and college teachers initiated by myself in 2017. And we used to arrange several online problem solving sessions to help the students who prepare for different national level competitive examinations like JAM, GATE, NET, etc. As a part of this series, today we have a session on integral calculus, and today's resource person is Dr. Nivetha Martin, Assistant Professor of Mathematics at Arul Anandar Autonomous College, Madurai. Dr. Nivetha did her MSc from Holy Cross, Trichy, and took her PhD from Bharatidasan University, Tamil Nadu. I'm sure that today's session will be really helpful to you, especially to those students prepare for JAM examination, because integral calculus is one of the major topic in the syllabus of JAM examination. So I'm sure that today's session will be really helpful and fruitful to you. I welcome everyone to this program, and I express my sincere gratitude to Nivetha for being with us. Welcome, Nivetha.
Good evening, everybody. So it is a second time for me to be a part of this Math Aspirants group, and I'm indeed very grateful to Dinesh here because it is he who is organizing so much of programs like this. So thank you, sir, for giving me an opportunity. And today in this class, we are going to see about the integral calculus problems, and this time I have taken the problems which have been appeared in the last 3 years, because when I was just go through the problems, all the problems were actually a very quite distinct one. It was not much a repetitive one, and already sir has shared the very first video lecture of the integral calculus, where I started with some prelims. So since sir has shared it already with you people, so I thought that I could not repeat once again all those things. So we can directly move on to the problem. So as I said earlier, I have taken 3 years of questions, and I have worked it on, and I like to share that solutions with you people also. So the very first question, so I'm just starting from the recent one, and I shall just go with the 21 and 20. So we'll move on to the very first problem. So considering an open rectangle, so it is of the form G equal to S comma T belong to R square, and the range of S and T has been given. And they have defined a function that is a map, it is T from G to R square. And also the function has also been given to us. That is, it is of the form T of X comma T. And here how the coordinates of your X and Y will be there, it has been given. And now they are just asking us to find what will be the area of the image, that is T of G. And we have given 4 options. So now, if we are just going to look at this problem, what the thing that we are going to take is nothing but an open rectangle. And we are going to find the image of this open rectangle. And the image of the open rectangle, it will be definitely a 2-dimension one, because look at the particular domain here, we have it as R square. So definitely we'll be having R square, it is a 2-dimensional one, so we'll have X, Y. So how will to have the solution approach to it? So here we are going to find the area, and definitely the general expression of your area in your R square will be your dx dy. And now since it is a dx dy over here, and now I have to find the limits of X. So I just want to find the limits of my X and Y. So how you can go on with that? So here, if I'm just going to look into this one, look at this, by T of S comma T will be of this form. That is pi S into 1 minus T by 2. So pi into 1 minus S by 2. So this is going to be my X and Y. So my X will be of this form and my Y will be of this form. So I'm just going to take into that. So here, pi s into 1 minus t by 2 will be my x, and I can have this as pi into 1 minus s by 2 will be equal to y. So I want to write my s t both in terms of x and y. So which is feasible we can see. And we have one more thing as my s is varying from that is 0 to 1, and I'm going to have t is also varying from 0 to 1. Ma'am, your mic is muted.
Hello, Nivetha, your mic is muted. Please unmute yourself. Yeah. Hello.
Yes.
Your presentation is, yeah, it's again
Yes, sir.
restarting. No problem.
So I hope you can now hear me, sir.
Yes, yes.
Yes, ma'am.
So now we are going to have the s in terms of y. So we'll see how we can get it. So pi into 1 minus s by 2 equal to y. So I can have it as pi into 1 minus s equal to 2y. And I can have 1 minus s will be equal to 2y by pi. And so I can have my s to be 1 minus 2y by pi equal to s. So now I got my s in terms of y. By using this, I can get my x in terms of t. So we'll just try it because only one will be the unknown here. So here let me go on here. So pi into, so I know what is my s. It is 1 minus 2y by pi. And here I have it as 1 minus t. So I think I can take this as my 2x. So here if I'm going to take a simplification of this, so it is pi into pi minus 2y. So this becomes pi here. So 1 minus t will be equal to 2x. So it will be left out. So pi can go off here. So I can have my 1 minus t to be 2x by pi minus 2y. And I can have 1 minus 2x by pi minus 2y is equal to t. So now I have got my t and I have got my s. So what I can find with these things. So what do I know? So I know that my s is varying from 0 to 1 and my t is varying from 0 to 1. All that I want to find is my limits of x and y. So how it is going to get varied. So using this two given things, let us go on like that. So maybe now I can have, since my 0 is less than s less than 1, and I can have 0 less than 1 minus 2y by pi, and it is less than 1. So what I can do now? So I'm just going to simplify this one. So I'm just going to add minus 1 throughout. So I get this term. So then if I'm just going to multiply throughout with the negative sign, the inequality will get reversed. So I can write this as 0 less than 2y by pi, and it is less than 1. Now I just wanted only the y. So what I can do? So I'm just going to multiply throughout by pi by 2. So that I'm getting the limit of y here. So I'm going to repeat the same for t. So what I can do? So as given, my t is varying from 0 to 1. So this becomes 0 less than 1 minus 2x, pi minus 2y, and it is less than 1. So I'm just going to apply in a very similar manner. So I can have here as minus 1. So less than minus 2x. So this will be pi minus 2y, and this is going to be 0. So here again, this is going to be again, it is 2x pi minus 2y, and it is less than 1. Okay, so now if I want to simplify this, so similarly, if I'm just going to multiply by pi minus 2y by 2, so what happens? So it is 0 less than x, and it is less than pi minus 2y by 2. So now I got the limits of x, I got the limits of y. Now all that I want to find is only the area. And as I said earlier, this is going to be, so a equal to, that is your dx dy. And we know that your integral, that is double integral dx dy will be also equal to double integral dy dx. But look at here, the limits of x, it is having the element y. So the variable y is also involved in the limits of x. So I think dx dy will do good. Limits of y are constant. So this becomes 0 to, so pi minus 2y by 2, and this becomes 0 to pi by 2. And here I have the dx dy. So now the integration is very simple because the integrand is actually a very constant one we have here. Only we have the integrating variables, that is x and y. So it's a very simple one. So 0 to pi by 2. So now with respect to x, if I'm going to integrate, I'm just going to get x. So it is 0 to pi minus 2y by 2, and I'm going to have only dy. So now it is 0 to pi by 2, and this becomes pi minus 2y by 2 dy. So what happens if I'm going to integrate? So since for the viewing, I'm just going to continue here. So if I'm just going to integrate with respect to y, so I can take this 1 by 2 outside because it's a constant. So this becomes pi y minus 2y squared by 2. So this becomes 0 to pi by 2. Since the lower limit is 0, so we'll concentrate only on the upper limit. So it is pi by 2. So it is minus y square. So it is pi square by 4. So this becomes again 1 by 2. So pi square by 2 minus pi square by 4. So this becomes actually 1 by 2. So pi square by 4, and this becomes pi square by 8. So we have the options over here. So option C is actually the right answer for this particular question. So now we'll move on to the next problem. So I'm just going to consider the region that is S, Y, Z. So it is a 3-dimension one. And I'm having the Z, that is 0 less than Z less than x square plus y square. And also the x square plus y square is less than 1. So what will be the volume of the G? So this is what it is, a given one. And here, since there are 3 variables will be involved because it is in volume, and here we have given only the range of Z from where it is varying. So it is 0 to x square plus y square. And we have given another one circular region in the xy plane. So it is x square plus y square is less than 1. So with this given information, how can we just go on with the solutions? And here we don't given any options as such. But then they are asking us to find out what will be the volume. So moving on to the problem number 2 here. So if I'm going to go with the volume, definitely it will be involving the triple integral. That will be your dv. So you can have your dv as your dx, dy, and dz. And now we are not given about the x limits or y limits. What is given is only the z limits. That is, your z is varying from 0 less than z less than x square minus y square. So since it is given only the z limits, so we just apply only with the z. So we need not worry about that. Okay. So given here is z. So as we know that though we change the order of integration, so the final resultant is not going to get changed. So now we are not going to worry about this as of now. So let's just go on with our z. So it is 0 to x square minus y square. So I'm just going to go on with your dz, and then I'm just going to focus on my dx and dy. So in this case, this is going to be, so it is only the z. So I'm just getting x square minus y square. So this is going to be dx dy. So now the triple integral has been reduced into a double integral. And look at the integrand, it is x square minus y square. And also, we have that xy region. So what is the xy region? So your xy region is something about your x square plus y square is less than 1. So of course, it is going to be a circular one. So once we have such a representations, we can directly use the polar coordinates. So we know that x is equal to r cos theta and y is equal to r sin theta, and your dx and dy, you are going to make it as r dr into d theta. So this is the simple substitutions you are going to make over here in polar form, and then you are going to have the limits of your theta and limits of your r as of now. And it is pretty well sure that what is your r. So definitely it is 1 over here, it is unity. And now what we are going to do then? See, we need to find the limits of theta, and of course the limits of r is very vivid over here. But then here we have a little confusions you'll be getting in terms of actually when we take about the theta. So let me explain as we are just proceeding it. So now we'll just give the value of your r to be 0 to 1. Okay. So let me just retain the value of theta for time being. Now we can have the substitutions here. So x is equal to r cos theta and y is equal to r sin theta. So what will be your x? This will be your r square cos square theta and minus r square sin square theta, and your dx dy will be r dr d theta. So this is a simple substitution that we are going to make by using the polar form representations. And now what happens to this r square? So now when I'm just going to have 0 to 1 here, so this is r cube I'll be getting. So this to be cos square theta minus sin square theta. So I can have this as cos 2 theta. So I can have it as dr, I can have it as d theta. So this is a very easier one because we have it as the simplification of cos square theta minus sin square theta. So we can represent that as actually a cos 2 theta. So now, so we'll get an idea that we can go on with the integration of this r cube with respect to r. So if I do so, what will I get? So this is going to be my r cube integrating will be r power 4, and if I'm going to apply the limits, it's going to be 1 by 4. And now the left out is nothing but your cos 2 theta and d theta. So now, when we are going to do such a polar representations, eventually we will always go on that theta varies from 0 to pi. So generally we don't have any second thought, no? Because immediately we say theta varies from 0 to pi, unless otherwise we are having a straight line intervention or something like that. When you just go on with a very circular region, we automatically take the theta varies from 0 to pi. And we'll focus whether the r values are right or not. So, but now why I'm hesitant to take out the theta value to be 0 to pi from the very beginning? So why can't I just directly take 0 to pi? So now, if I'm going to take the limits of this one cos 2 theta, and if I'm going to integrate this, definitely I'll be getting sine 2 theta by 2. And check out the limits, that is 0 to 2 pi. Obviously, you'll be getting the volume to be actually a 0. But then, your question is not like that. So it is asking around some 2 decimals value. So now this provokes another thought for us. So definitely there will be something more than taking the value of theta to be 0 to pi. So something more we have to think over it. So definitely this is not going to be 0 to 2 pi in this case. But why? Why it is not so? So now, if you are just going to look at the limits of your z, that is 0 less than z less than x square minus y square. Okay, fine. So you have certain things over here. And definitely, this is going to be a reflection of your in your 2-dimensional one. And we know that 0 less than z less than x square minus y square. So in this case, so we are going to find the value of your theta over here. So this is going to be your x square minus y square. And in your xyz plane, definitely you are going to have actually used to be 0. So in this case, you have your x square equal to y square. So x is equal to plus or minus 1. So in this case, you are going to have two things. So maybe I can take it as y is equal to minus x one case and y is equal to plus x. So here, this is going to be your y is equal to x. And this is going to be your y is equal to minus x. So in this case, so what will be my dy by dx? So that is your tan theta, no? So dy by dx will be equal to minus. But in this case, your dy by dx will be equal to your 1. So here, your theta value will be equal to minus pi by 4. And here, your theta value will be equal to pi by 4. And then, this particular angle will have here minus pi by 4 and this will be pi by 4. So you have these regions to be covered over it. So in this case, you are going to have twice the region of it. So 1 by 4, you have twice. So here you are going to have to be minus pi by 4 to pi by 4. And then you are going to have it as your cos 2 theta d theta. So in this case, this is going to be 1 by 2. And cos 2 theta by 2, this is going to be sin 2 theta by 2. And then you're going to have minus pi by 4 to pi by 4. So this is going to be your 1 by 4. And this is sine. So 2 into your pi by 4. And it is minus sine 2 into your minus pi by 4. So in this case, you're going to have it as 1 by 4. So sine pi by 2 is 1. So sine of minus theta. Here also you will have it as minus pi by 2. So minus minus is going to be plus. So 1. This is going to be 2 by 4. This is going to be 1 by 2. And this is going to be some 0.5 around. So in this case, you can able to get the area for this particular value of this integral over here. So the volume to be has equal to 0.5. So we'll move on to the next question. So here, if G is the region in R square given by G equal to, so therefore x comma y belongs to R square. And here again, we have that x square plus y square is less than 1. And now here is given here your y. So your y is nothing but x by root 3 less than y less than root 3x over here. So it is less than, and x greater than 0 and y greater than 0. Now they are asking us to find the value of this 200 by pi double integral over x square dx dy. So this is also not given any options for us. And now we are going to find the answer for this one. So you can go on to this particular third problem. So now you are going to find the value of 200 by pi. So double integral over g. So x square dx dy. So what is the value of this one? So you're going to find. So what is given is, so your g is nothing but as given here. So it is at a fall x comma y belongs to your r square. So x square plus y square is less than 1. And here it is given your x by root 3 less than y less than root 3x. So now it is given some region over here. So let us just check out what is the region. So it is given here already we have x square plus y square less than 1. So of course it is going to be a circular region here. And now we have been given as x by root 3 less than y less than root 3x. So now definitely this is going to be a straight line. So I can have this, So I can have this to be your y is equal to some x by root 3 and your y is equal to some root 3x. So this is going to be generally a straight line over that. So maybe I can have this one. So I can have this to be y equal to x by root 3 And maybe I can have another one line over here. So this is going to be definitely root 3x. Okay. So now I just want to go ahead with the respect to another one. So let us have beside this one. So what happens, your 200 pi, so this to be, and here you're going to have your x square dx dy. So if I just want to find the value of this one, maybe I can go with another one conversion of this Cartesian form to the polar form. So what I can just make here is, I can have my x is equal to r cos theta and y is equal to r sin theta. So the same thing. So dx dy, I can have the same here as r dr and d theta. So in this case, I can have this as, so 200 by pi, this becomes, so x square will be r square cos square theta and dx dy will be r dr d theta. And now all that I have to do is, I want to find the r and theta. So here r will be generally varying from 0 to 1 because it is given here x square plus y square is actually, it is less than 1. Now I just want to find the theta here. So here also I cannot simply give with the like 0 to 2 pi. Here also there is a difference over here. So what is that difference? So now your y is equal to x by root 3. Okay. So your dy by dx will be equal to 1 by root 3 here. Because this is a case when your y is equal to x by root 3. And this case I can have dy by dx is equal to just root 3 if I'm going to differentiate. So this becomes my tan theta will be equal to 1 by root 3 and tan theta equal to root 3. So you know very well that this particular one. So this is going to be x by root 3 here. This makes an angle. Again, this makes an angle over here. So this is going to be, so dy by dx. So I can have here, so tan theta will be equal to 1 by root 3. So theta will be tan inverse of 1 by root 3. So again, theta will be here tan inverse of root 3. So in this case, I can have here as, so this one is going to be your pi by 3, another one is going to be your pi by 6. So one is a tan 30 value, another one is a tan 61. So here now we can have this as, so this is going to be pi by 6 and this is going to be your pi by 3. So now you are going to just have this one. So this is going to be your pi by 6 to your pi by 3. So this thing you are going to find it, the limits over here. And now this is going to be r cube. So with respect to r, so it is going to be r power 4 by 4. So 0 to 1. And here we are going to have cos square theta into d theta. So it is 1. So definitely it is 200 by 4 pi. And now it is pi by 6 and pi by 3. So this is cos square theta. So I can just go on this as, so I can have it as 1 plus cos 2 theta by 2 into d theta. So for a simplification, so now what happens is, so 200, so it will be 100 by 4 pi. Okay. So we can just simplify it. So 450 so will be 25 by pi. So I can just look on with that. So now this is going to be 1 plus cos 2 theta. So this will be theta and this will be sine 2 theta by 2. So pi by 6 and pi by 3. So this becomes 25 by pi. So here it becomes pi by 3 minus pi by 6. So this here, and because I have applied for theta separately, this will be 1 by 2 over here. So I can have this as sine 2 pi by 3 and this will be again sine of 2 pi by 6. Okay. So we have 25 by pi over here. Could anyone tell me what could be pi by 3 minus pi by 6? Yes?
2 pi by 3.
Okay. So I can have it as pi by 6 over here. So this will be 1 by 2. Could anyone tell me what be the value of this one? Sine 2 pi by 3 and 2 pi by 6. If I'm right, if I write 0 here. So this will be again 120. And this we know the value of 2 pi by 6 will be a 60. So you have root 3 by 2 in both the cases. So this goes off. Actually, it will get vanishing this value. So you have some 25 by 6. So it is something like 4.166. In that range, you will be having the value of this particular one. So this is one, two problems that we have been discussed. No, one is regarding the volume and another one regarding the area of it. So though it looks as though given the range, if I'm just going to give a look at the problems. So it is actually with the volume and this is going to deal with an area. But still, if we just give a glance of it, we have the circular region. It resembles to be a little bit of similarity will be there. But then the way we are doing it and it looks entirely a different one. And now we'll go on to the another one problem. The fourth one we'll just see. It is also quite interesting one, which is involving the gamma functions. So let A and B be positive real numbers such that A is less than B. And given that your limit n tends to infinity, so it is 0 to n e power minus t squared dt equal to root pi by 2. And then they are asking us to find the value of this one as n tends to infinity. So here these options are given. So let us see how to solve this problem. So for this, we have to know one result. So this is fourth one. So we have to know the result of this one. So e power minus 80. So it is t power n minus 1 dt. That is equal to your gamma n by a to the power n. This is what I was just telling about this gamma formula over here. So just involving all these things. So we are going to utilize this one. So now what I want to find is, I just want to find the value. So when my capital N tends to infinity, so 0 to n, this is going to be 1 by t square. So e power minus 80 square minus e power minus bt square dt. So I just want to find the value of this one. See, if I'm just going to look into it, this no. Later I can just go on with this applying of the limit. Let me just focus on this one here. So when I can have it as n tends to infinity, so I can directly write this 0 to infinity over here. So 1 by t square. So it is e power minus 80 square minus e power minus bt square dt. So what I'm going to do this is, I'm just going to consider the first one, the first part of the integral. So this is going to be the similar, no, because 0 to infinity, e power minus 80 square. If I'm just going to have it for my t square, then this both are going to be the same. Only the variable is going to get changed. That is e power minus bt square. So this is going to be dt and this is going to be dt. So let me just going to consider this one. Let me just have it as for my convenience. I'm just going to take it as I2. So I1 is nothing but it is integral 0 to infinity. So e power minus 80 square, this is going to be t square and this is going to be dt. So I'm just going to simplify this one. Let me take this as t square equal to x. So I just take t square equal to x. So I can have it as 2t dt equal to dx. Okay. So I can have my dt to be, okay, dx by 2. So instead of d square, I can have it as, I can have this one, it's root x, because t is equal to root x, I can have it as. So this, even I'm going to change the limits, no, it's not going to be the one. The similar thing, I'm just going to x is 0 to infinity. So e power minus 80 square. So t square substitution is ax. This is going to be also, So t square is actually x. And now my dt is going to be dx. So I can have it as my 1 by root 2. So this is going to be root x. So x power 1 by 2 and x. So this I can have here as 1 by 2 integral 0 to infinity. So I can have this as e power minus ax. So I can have this as x power minus 3 by 2 dx. So if this is going to be my I1, so my I2 will be the same one. In this case, I'll have it as b, that's all. My bx, x power minus 3 by 2 dx. So if I'm just going to, because this is I1, no? So sure. I1 minus I2. Okay. So now if I'm just going to write the same thing here, so my 1 by 2 will be common. So I can have it as 0 to infinity. So I can have this as e power minus ax, x power minus 3 by 2. So dx, and here this will be 0 to infinity, e power minus bx, and it is x power minus 3 by 2 dx. So here I can have this 1 by 2, 0 to infinity. So e power minus ax. I can write x power minus 3 by 2 as x power minus 1 by 2 minus 1 dx. So minus 0 to infinity, e power minus bx, x power minus 1 by 2 minus 1 dx. So now we may wonder, so what is the need for me to go on with this? Because I just want to apply the very first beginning, no? So what is the formula I have taken for it? So t to the power n minus 1, I can have it as gamma n by a. So whatever will be the coefficient of t. And here x power minus 3 by 2, I have written as minus 1 by 2 minus 1. So this is going to be gamma of minus 1 by 2. So this is going to be, that is half, and this is going to be here gamma of minus 1 by 2, and here it is going to be a power minus 1 by 2, and it is gamma of minus 1 by 2, and I'm going to have b to the power minus 1 by 2. This is going to be 1 by 2. So gamma of 1 by 2. So we know the answer of gamma of 1 by 2 is pi by 2 would be that is, but what will be the gamma of minus 1 by 2 is nothing but minus 2 root pi. And I can have this as a to the power minus 1 by 2. So here also same thing, but in this case I have it as 2 root pi. So I have it as b to the power minus 1 by 2. So I can have it as just root pi alone. So this becomes, okay, you have it as root a with a negative, and this comes root b. So here it becomes root b minus root a. So since in this particular problem, the options are given. I think I can, yeah. So the options are given for us here. So we can move on to the next problem. Yeah. So this was the options we had it. That is root pi into root b minus root a. So now we'll move on to the next question. So here it is f. It is a function defined from 0 to pi to r. And we have defined the function of this form. So we function is taking the two values in the range from 0 to pi. That is 0 to pi by 2, it takes a value x minus pi into e power sin x. And pi by 2 to pi, it takes another value x e power sin x plus 4 pi pi. Now all that we have to do is that we have to find the value of this integral. So now it is a very simple task, because we are just going to integrate the two integrands with respect to the limits. And since, of course, it is going to be only a single integral. Okay. So it is going to be an easy task for us. But let us go on and see how far it is easy for us to go on like that. So maybe we'll just go for the fifth problem here. So now all that I want to find is 0 to pi my f of x dx. So it is nothing but 0 to pi by 2 and f of x dx. Plus again pi by 2 to pi f of x dx. So what will be my f of x over here? So it is x minus pi e to the power sin x. So dx. So again it is pi by 2 to pi. This will be x e power sin x plus 4 by pi dx. So now integrating this one. Imagine and see, this is not just involving either an algebraic or exponential, but it's a combination of both. And then you want to consider this as u, v, and then you want to integrate, and maybe since it is an exponential function, so it goes on and on. So now, how to go on with this one? So it's a very simple one. We are going to make use of two simple theorems over here. The very first one is, so it's a very beautiful results that we have obtained from the things. So integral a to b f of x dx, this will be again equal to integral a to b f of a plus b minus x dx. The second one, it is integral a to b f of x dx. This will be equal to a plus c, b plus c, f of x minus c dx. So we are going to apply these two results and we are going to get it. And let us see how we are going to get it. But you may think over a while, why can't we integrate when we go on with that? But it is a time consuming one. If you just start to integrate and apply the limits, because the two different integration and a bit lengthier one. But if you are going to use these two results, I think you'll be getting the result very easily to go on with that. So I'm just going to focus on the first integrand. Now my ultimate aim is to make the limits of both integrals to be the same. So now I will not touch the limit for the second one, but I will touch the limits of the first one. So I think I want to apply the second result. The second result I will be applying here in the same way. So how can I make so? So now this will be equal to 0 to pi by 2. So I'm just going to make this as, I'm just going to add pi by 2. That is, my c is pi by 2 here. Okay. So this becomes x minus c. So in the place of x, I'm just going to make it as x minus c. So what is that? It is going to be x minus pi by 2. So x minus pi by 2, this becomes minus pi. So no change over here. The place of x, I'm just going to replace by x minus pi by 2. So e to the power sine of, in the place of x, x minus pi by 2. Now again, this is going to be plus. I'm not going to disturb the limits of the integration, but I'm going to disturb the integrand. So for that, I want to apply the first one. So it is a plus b minus x. So pi by 2 plus pi will be 3 pi by 2. So 3 pi by 2 minus x. So this will be 3 pi by 2 minus x e power, it is sine of 3 pi by 2 minus x. And there will be no change in the dx. So dx comes as such. And the next one will be just to 4 by pi dx, subjecting the same limits over here. So now, by using the two results, what I have done one is, one of the greatest advantages is the limits of the integral are same now. So now my integration part will be a little bit of easier one. Okay. So now what I can do this one. So I think I can club it because the limits of the integration are one and the same. So I do not worry about the thing. So it is pi by 2 to pi. So x minus, I can have 3 pi by 2. Okay, so this comes here. It becomes e power. I think I can have this as x minus pi by 2. I can have this as minus cos x. Why? Because if I'm going to have it as pi by 2 minus x, so definitely I have a negative. So pi by 2 minus x, so it is cos x. Now this again, I have 3 pi by 2 minus x. So again it is 3 into, you'll be having, this becomes pi by 2 here. So 3 pi by 2, so it is 270. So you have again a negative sign. So it's in the third quadrant, so we have it as cos x. Now you see, other than this 4 by pi, x minus 3 pi by 2 e power minus, and it is plus 3 pi by 2 minus x. So whatever might be, these terms will get vanished off. And the left out term will be 4 by pi dx. So what happens now? So now my integrand has been reduced to just 4 by pi dx. So how simple it is. So my 4 by pi is obviously a constant. Now my integrand is just 1. So dx. So 4 by pi, this becomes pi minus pi by 2. So 4 by pi, so into pi by 2. So the answer is just 2. So without doing any such of integrations, assuming u, v, all those things. So by using these two results alone, we are able to get the answers of the solutions. Okay. So now we'll just move on to the next one. So now this is actually the question which has been asked in 2021. So this is also quite an interesting one. So we'll see how to go on with this particular problem. Say let P and T be positive real numbers and let dt be the closed disk of radius t. So it is centered at the origin and your dt has been given us, so therefore x comma y belongs to r square. So your x square plus y square less than or equal to t square. Now we have defined your I of p comma t. So to be your double integral dx dy. So it is given as your p square and all those things. And now what you are asked to find is when the t tends to infinity, because it is going to be a function of p and t, the resultant one. So your I of p comma t as t tends to infinity is finite. Okay. But then under what cases it is finite? So whether your p should be greater than 1 or p. So all the three possible conditions it is given. And if neither of the conditions are satisfied, you can conclude that for no value of p. So now let us just to see that how to go for this particular problem. Okay. So now, as we just said that, so your I of p comma t, this will be your double integral over dt. So this is going to be dx dy. And then it is going to be your p square plus x square plus y square, the whole part p. And also it is given that it is a closed disk of radius t. So definitely it is x square plus y square, it is less than or equal to t square. Okay. So now it is a closed disk because it is your integral over this closed disk. And we know that it is a closed disk. We can just go on with the polar form of representations. So how to go on with that? So you know very well that your dx dy will be equal to r dr d theta, and it is a closed disk. So we need not worry about this one. So your r will be varying from 0 to t because it is given, the radius t is given in the question. So the radius is actually given as t and it is origin over here, and it is going to be a closed disk. So whenever it is going to be a very close to region over that, so here we not worry about this theta also. So your theta is varying from 0 to 2 pi. Okay. So, and we know that your t will be equal to r. So your x square plus y square will be equal to r square, and so it is going to be your t equal to r over here. Okay. So we know the general representations. So now what can we do that is, so your r is going to varying from 0 to t, and your dx dy, it is going to be r dr d theta. And we can have this, your x square plus y square is equal to r square. It's the general representations. So I'm just going to have it as r square. And this is the whole part p. And this is going to be 0 to 2 pi. So it's a very simple one. So first, let us simplify this particular integrand, and then we'll move on with this one. So here, what substitution you can make here is, you can take it as your p square plus r square is equal to some u. Okay. So your 2r dr will be equal to du. So your r dr will be equal to du by 2. Now, suppose when your r takes a value 0, so when r equal to 0, your u will be equal to p square. So u will be equal to p square. When your r is equal to t, and definitely your u will be equal to p square plus t square. So this case, so I can make this as 0 to 2 pi, and I can have this as, this is going to be your p square, and this is going to be p square plus t square. So r dr, this is going to be your du, this is going to be your u to the power p. So this is a case. So this is going to be your I of p comma t. Now I just want to say that when your t tends to infinity, whether it is going to be a finite for the values of p, and I can say that for the ranges of p also. So what is the first case? Because in option it is given when your p equal to 1, when your p is greater than 1, when your p is less than 1. If neither of the conditions are satisfied, as I said earlier, so the last option will be your answer. So now we'll go with the case 1. So what will be your case 1 is your p equal to 1. So what happens when your I of p comma t, whether it's finite or not? So now it is going to be 0 to 2 pi. Okay. And you can have this one, d theta. Okay. So now this is going to be 1 to 1 plus t square. So it is du by u, and it's going to be d theta. So this is going to be very simple over here. Since it is going to be your r dr, so du by 2, so then I can have this 1 by 2 here. Yeah, I can have here also it is 1 by 2. Okay. So now it is irrespective whether you with integral du or d theta. So we can first have the d theta over here. So if it is going to be d theta, then definitely it is going to be 2 pi. So I left out with the pi. This will be 1 to 1 plus t square, and this is going to be du by u. So we know that it is going to be log u. So it is 1 to 1 plus t square. So now what happens over here? So now it is going to be pi. So it is a log of 1 plus t square, and minus it is going to be log 1. And now this is going to be my I of 1 comma t, because your p is equal to 1. So now what happens when your limit t tends to infinity, I of 1 comma t here. So if your t tends to infinity, and log 1 definitely going to be 0. So this is going to be 1 plus infinity and log infinity. Definitely it is not going to be a finite value. It is going to be an infinite value. So p equal to 1 case is ruled out. So we are not going to get the answer for this one. And now let us go for the next case. So what is the next case is? So let me go with the case 2. The case 2 was actually my p is actually less than 1. Okay. So what happens to my I of p comma t? So what will be my I of p comma t? So in this case, this will be 0 to 2 pi, and this will be my p square plus t square. This is going to be du u power p and d theta. So what I'll try to do is, let me just integrate with respect to theta, and here also I'll be having my 1 by 2 because it will be r dr will be my d by 2. So if I'm going to integrate this, I'll be left out with only pi. This will be my p square. This will be my p square plus t square. This is going to be du u power p. So this is fine. So now if I'm just going to integrate, what happens? So it is going to be u power, okay, because it is u power minus p, no? So it is going to be minus p plus 1. And here it is going to be minus p plus 1. Okay. And there's going to be p square and p square plus t square. So now the denominator part, I can just go on like this one. So it is minus p plus 1. I'm going to take this one. So what will be my u here? So it is p square plus t square. It is minus p plus 1. It is minus p square and becomes, it is minus p plus 1. Now this is going to be my I of p comma t. Now I want to check when my t tends to infinity. See, when my p is less than 1. So I can just say that p minus 1 is less than 0. And I can have this as my minus p plus 1 will be greater than 0. So in this case, if I'm just going to go on with this one, I'm going to apply my t tends to infinity. So definitely in this case, I'll be getting only infinity. Okay, because I cannot make it to the denominator part because it is greater than 0. This part is actually greater than 0. But in a similar case, if I'm going to go with the next case of case 3, okay, so what will be my case 3? So p will be greater than 1. Okay, so p minus 1 will be greater than 0. So I can have minus p plus 1 will be less than 0. So in this case, if my minus p plus 1 is actually less than 0, then definitely I can bring to the denominator the form. Okay, so I can go on with this one. So since it is less than 0, so I can just bring it here over there. Okay, so this will be my p minus 1 if I just bring to the denominator part. So this case, I can just save my t tends to infinity, so it becomes 0, and this part remains as such. So I'll be having pi by minus p plus 1 minus p square, and in this case I'll be having minus p plus 1. So definitely this is going to be my finite one. So now my I of p comma t is finite when my p is greater than 1. So these options I can make it. So when my p is actually greater than 1, my condition is being satisfied. So I go with another problem. That is, I have a function here from R to R. So it is a continuous function such that for all x belongs to R, it is 0 to 1, f of x t dt equal to 0. So I just mark this as number 1. And then I have given 4 options are there. So whether there is an f satisfying 1, that is 0 has infinitely many points, but it is not identically 0. That is, it is not taking 0 at all places, but infinitely at many points it takes. Then there is an f satisfying 1, it takes both positive as well as negative values. And then we have another option that it is identically 0 on open at 0 and 1, but not on whole of R. But look at the last option. So it takes 0 the whole of R. So I just want to check which of the given options is right. So how to go on with this one? Okay. So here, what is given to us is 0 to 1. It is f of xt dt equal to 0. And here, it is a function of x and t. And certainly that you must take that your x and t, the two variables must be independent one. Okay. So in this case, let me go with xt equal to u. So I can have my x dt will be equal to du. So I can have my dt to be du by x. Definitely there will be a change of limits also, because only the limits of t are there. That's why I'm just telling only the limits of t has been given. So definitely it must be an independent one over here. And since your t equal to 0, okay, so definitely your u also will be equal to 0. If your t equal to 1, your u will be equal to x. Okay. So once we're going to change this variable over here, so what I can do? So what happens over here? So definitely the given one, so it is 0 to x, and it's going to be f of u, and what will be your dt? Your dt will be du by x. So du. So I can take this 1 by x, and in this case, x certainly not equal to 0 over here. So this is equal to 0. So what is given? We have just rewritten in terms of u. So now we are going to discuss the different cases over here. So maybe here we are not going to take x equal to 0, but definitely there are two cases. Suppose when x is greater than 0 or when x is less than 0. So what the things you can go on with that? If you're just going to look at this particular one, which I've started, if I'm going to integrate and apply the limits, definitely I will be getting only a function of x. So there is no doubt in that. So let me take the resultant to be some function that is g of x. So 0 to x f of u du. You can take g of x, h of x, anything as per your wish. So because f always go on with g, so we take g of x over here. So now I'm just going to get it. What is the derivative of this one? Because I just want to check whether my f is getting the value 0 or not for whatever values of x. So what is the thing? What is the f value I'm just going to have? So g dash of x. So here, since my 1 by x cannot be, because it is equal to 0 here, so this will not be 1. So this will be equal to 0 here. Now, here I'm just going to take this one. So as of now, I'm not going to go on with this one. Okay. Yes. So this is not equal to 0 because since I'm going to equate to 0, so 1 by x cannot be equal to 0. So I take this to be equal to 0. So when I'm going to have the integration of g dash of x, so we know that always we just go with this 1. So we have it as f of x, and this is going to be a constant. So this one 0, we take it here. And of course, it is going to be 0. So your g dash of x, so it will be equal to f of x, and this is going to be again 0. So your f of x equal to 0. So maybe in the case when your x is greater than 0, so the same thing is going to repeat it when your x is less than 0 also. So now what happens that when my x is equal to 0? That is more important. So when my x is equal to 0, so it is 0 to 1, it is going to be f of 0, this is going to be dt. So f of 0, I'm not sure what is it. So I'm just going to take, so 0 to 1 dt here. So of course, what is given is actually 0 in the question. So this is going to be my f of 0 into 1. So here, in this case, my this might not be equal to 0, but definitely I'm going to get my f of 0 equal to 0 over here. So in all the cases, so definitely over the entire R, for whatever values of x, your f is going to take the value 0. So it is f is identically 0 on the whole of R. So this was the thing. So we get the last options over here. And coming to the next question. So now this is also a very interesting questions over here. So now I'm just going to take one here. It is a function from 0, 1 to 0, infinity. So this is going to be a continuous function. And now we have one inequality, that is f of t the whole square is less than 1 by 2, 0 to t, f of h ds. So this is for all t belongs to the closed interval 0, 1. Okay, fine. They're asking of which of the following will be the true one if this condition is being satisfied. So if this for inequality, which of all the following 4, which will be the right one. So we'll just go on with that. So prudential is an 8th problem over here. So what is given, that is my f of t the whole square. This is going to be less than, it is going to be 1 by 2, this is 0 to t, and f of s ds. So this is for every t belongs to 0 to 1. So the nature of the function is given. It is a continuous function, so its domain and codomain. Okay, fine. Now what I want to just go on with that. So this is for all t that belongs to 0, 1. Let me just take the value t to be equal to 0 as of now. So it is f of 0 the whole square less than 1 plus 2 into, this will be 0 to 0. So we know that my f of 0 the whole square, it is less than 1 because this is holding for all the t's, it is belonging to 0 to 1. So of course it must be true for each and every value. So when t takes the value, I have f of 0 less than 1. If I'm just going to look at the options, from the given options, I can rule out certain things because option 1 and option 3 are actually having the less than in equal because f of t is a less than. Option 2 and option 4, that is f of t is greater and f of t equal. So looking at the options, we can directly rule out the 2 and 4. Now the left out options are the 1 and 3. So f of t should be less than 1 plus t, or f of t should be less than 1 plus t by 2. So if a function has been defined from the domain 0 to 1 and to 0 to infinity, so having the codomain. So if these things are there, so what shall we do? So since option 1, so f of t must be less than 1 plus t, and my f of t must be less than 1 plus t by 2. So these are the two options over there. So now, how we can reach the right solution over here? So f of 0 is less than 1. Okay, fine. As of now, there is no go on with that. So here, we can take this particular one as the inequality is p. Okay. So I can take f of t the whole square. This is going to be less than 1 plus 2, 0 to t. So f of s ds. So let me take this to be p. Okay. So I can take this to be my q1. F of t less than 1 plus t. And this I can take it as my q2. Okay. So f of t, it is less than 1 plus t by 2. So if this is true, okay, either of the options must be true. So I can say p implies q1, or it must be your p that implies q2. So now, to find this one, we are going to go with a negation. So what is that negation is? Your node q1 should imply your node p, and your node q2 should imply your node p. So which of these two things is going to get satisfied? So that will be the right option. So what will be my node q1? So my node q1, since it's an inequality, I just take it must be 1 plus t. So what will be my node q2 is nothing but my f of t must be greater than 1 plus t by 2. So I want to choose one f of t in such a way that this could be satisfied. And we know that 1 plus t is greater than 1 plus t by 2. Okay, that is fine. So now in this case, let me take my f of t to be 1 plus 2t. So 1 plus 2t is greater than 1 plus t. And in that case, your 1 plus 2t must be also greater than 1 plus t by 2. Okay. So now we'll go on with this one. Maybe I just go with this second one. Okay. So what is your f of t as of now? 1 plus 2t. So your 1 plus 2t is greater than 1 plus t by 2. As per we take it as. So this is fine because it is not q2. Now this one should satisfy my node p. So what is my node p will be? Your f of t the whole square should be greater than this one. Okay. So what will be your f of t the whole square? This will be 1 plus 2t the whole square. Okay, let me find it. What is that? So 1 plus 4t square, and this will be 4t. So let me find the right hand side of the inequality. This is 1 plus 2, 0 to t. So what is the f of s? This will be 1 plus 2s ds. So this will be my 1 plus 2. So this will be s plus 2s square by 2. This will be 0t. This will be 1 plus, so 2t. This will go off, so this will be 2t square. Okay. So we're just going to compare this 4 and 4. Okay. So in this case, definitely this is not going to get satisfied because it must not, isn't it? But then here, this is actually satisfying your P, but it is not satisfying your not P. So in this case, we can say that your Q2 option is being not satisfied. So your only option will be your f of t must be less than 1 plus t. So this will be the right options here. So now another one interesting and easier one also will go that, because it is something more of the triple integral. See, your B is again given as actually set of all x, y, z. So it's again a volume one because it's a triple integral. And your function is given, that is your u of x comma y comma z. So if you just look at the functions, we'll be just wondering what a big function it is, how to integrate, how to find the dou u and all those things. But it is very simple. So we are going to make use of only one result over that. And if we are very well aware of that result, then this problem is pretty well very easier for us to go on to that. So what is given here? So the given one is, you are going to find the value of your triple integral. So we have given what is the region over there. So it is going to be dou square u by dou x square, and this is going to be dou square u by dou y square, and this is going to be dou square u by dou z square, and this is into your dx, dy, and dz. So now we can write this particular one as, so this again equal to your triple integral over b. So we can write this as the divergent of the gradient of u into dv. Now this again we can write it as double integral del u into n cap ds. So this is very simple because we'll be dealing with lots of results when we go with vector calculus, when divergence and gradient and how to relate your triple integral with your double integral. And when we do with all those things, so this is one of the results that have been applied in most of the problems to convert your triple integral into a double integral, because to simplify this one, so we have del u because it is the del operator, and then we have the n cap that be the outward normal we have it. So we have a general formula for your n cap. It is something but your del f by modulus of your del f. So f is something about the surface of it, no? So you find the gradient of the surface. So what is the surface over here? So the surface is actually, it's a spherical surface, and then you know what is the u function over here. So now the things will become very easier. So what is your n cap? So as I said, it is del f. So your f will be nothing but your x square plus y square plus z square equal to 1. So your del f is nothing but, because it is the scalar value function, will be converted to a vector value function. So that is a gradient. So you have 2xi. So you have is 2yj plus 2zk, because we know it is del is equal to I into dou by dou x, so plus j dou by dou y. So del phi or del f. So we go with the del f will be your this one. So dou f by dou y plus k into dou f by dou z. Okay, this comes. So what will be your modulus of your del f? So this will be, so your square root of again, so 4x square, so 4y square, and 4z square. So what will be your n cap? So your n cap will be 2xi, 2yj, and 2zk. Again, you're going to divide it by, so square root of, you have it as 4x square plus y square plus z square. This value is going to be 1. So square root of 4 is 2. So if you have this 1 in the numerator also, it's common. So xi, yj, and zk. This is going to be your n cap. So now all that you find is your dou u. Okay. So del u is nothing but your dou u by dou x. So because it is a dot product. So del u is nothing but you can have it as dou u I, dou u j, and dou u 0 all with that. So you can have it as, since it's a dot product, you can have here. So this is going to be your double integral. So del u by n cap into ds, it is nothing but the double integral here, x into dou u by dou x plus y into dou u by dou y and plus z into dou u by dou z, and then you can have it here as your ds. So it's nothing but your surface integral with respect to your x and y, you go on with that. So it's very simple. So now what is your u? So it is u of 1 minus x square minus y square minus z square the whole square. It is not sine of the whole function, it is sine of the function, the square. So what will be your dou u by dou x? So sine of thing, if you're going to differentiate, it is cos. So it is 1 minus x square minus y square minus z square. This is going to be the whole square. So again this 2 into 1 minus x square minus y square minus z square. And here it is going to be minus 2x. Now similarly, you can go with the same one. It is going to be cos, and it is going to be 1 minus x square minus y square minus z square the whole square. And this is 2 into 1 minus x square minus y square minus z square into minus 2y. So you go with the same one, dou u by dou z. So this is cos. So 1 minus x square minus y square minus z square the whole square. So 1 minus x minus y minus z square minus 2z. So this we have found. So now all that you want to find is into x. So you have to go with your into x over here again. So when you go like this one, so triple integral, let me write directly. So what will be having here? Into x, into and y, all these things. And if I'm just going to add, I have to multiply each of the things, that is dou u by dou x into x, dou u by dou y into y, dou u by dou z into z. And I want to add all those things. And if you go look at the components, this cos of and 2 of, that is 2 into, is quite common. So if I'm just going to take this, so it is cos of 1 minus x square minus y square minus z square, the whole square. So it is 2 into again 1 minus x square minus y square minus z square. So I'm going to add these two. Okay. And I'm just going to add this one. So minus 2, this will be. So x square plus y square plus z square. It's going to be my ds. Okay now. Okay. It's only a double integral one. So now, can I take the value to be 0? So you may wonder that what that we have derived is so much, and finally, ultimately, you are giving the value to be 0. So how is that possible with that? See, we know that x square plus y square plus z square is equal to 1. But look at over here. 1 minus, it is x square plus y square. If I take the minus sign over here, this is going to be actually 0. Okay. So the entire term will be getting vanished off. So the final value of this answer to be actually 0 here. So we go with the next question. So I just don't want to display the questions by, because it's a very single line questions. So we'll go with the nth one. So the value of limit n tends to infinity 0 to 1 e power x square sine of nx dx. This is a question. So if you just look at the integrand, it may just frighten you, because it is e power x square sine nx. Oh my god, okay, you'll go with the substitutions and all those things. So now we are just going to not solve it very step by step, not the entire solutions we will do, but we are just going to integrate only once, and then we are going to just find the value of it. So we'll see how we are going to do on with this one. So let me take my in is equal to 0 to 1. So it is e power x square, and then it is sine of nx dx. Okay. So now we'll go with the same thing. So we take u equal to e power x square. So dv will be taken as sine nx dx. So I go with the du equal to e power x square into 2x dx. So v will be equal to minus cos nx by n. Okay. So only one time we'll go on with that integration. So uv. So it is going to be e power x square. So I just go with the minus cos nx by n. Okay. So minus, so plus integral. So I have it as 1 by n. It is going to be 0 to 1. So you go with 2x e power x square cos nx dx. So what happens if I'm going to apply the limit over here? So I just take minus 1 by n. Okay, so e power. So it is e power cos n. This is going to be minus 1. No doubt in that. Okay. So here this is going to be my 1 by n, 0 to 1. So 2x e power x square cos nx dx. Now you just imagine that if I'm going to repeat the same thing, yeah, it goes on and on. So now how can I simplify this one? So how can I just make on with that? So here in this case, I'm just going to take the modulus. So 1 by n. So it is e cos n minus 1 plus 1 by n. It is 0 to 1. So it is 2x e power x square. So cos nx, and so it is dx. So now this is going to be less than or equal to minus 1 by n. So e power cos n minus 1 plus again, I just go with the 1 by n, 0 to 1. So it is 2x e power x square cos nx dx. Okay. So this becomes 1 by n e power cos n minus 1. So just 1 by n I can have it as 0 to 1, 2x e power x square. It is cos nx dx. So this, now I just want to find the value of each of the things separately. So what happens? So you can have it as e cos n minus 1. So this will be less than or equal to, so the modulus of e cos n plus 1. So this will be, no, I can write it as e plus 1. Okay, because we know that the modulus of cos n is less than or equal to 1, and we'll go on with this. So because certain things which the results are known, I'm just moving a little quicker. So now what happens here is integral 0 to 1. So 2x e power x square. So this is going to be cos nx dx. So this I can write as less than or equal to integral 0 to 1. This is going to be 2x e power x square. So cos nx dx. So in this case, I can write this as integral 0 to 1. So 2x e power x square, and this is going to be cos nx dx. Okay. So we know that the cos nx is going to be 1. So now I just want to find what will be this particular value. So we know that what is given in here, it is 0 to 1, integral x. So this is 1. So e power 0 less than or equal to e power x less than or equal to e, because we are raising to the power e. Okay. So in this case, so of course this also will be correct. So 0 less than or equal to x. If I'm going to have it as x e power x less than or equal to e. So how did I get this one? Okay. So this is something, no, suddenly that how can we go on with your 0 less than or equal to x less than or equal to x, this one. So we know this result. So when you 0 less than or equal to x e power x less than or equal to actually x. Okay. Because we are, sorry, it's going to be e power x. But we know that our e power x is less than or equal to e. So 0 less than or equal to x e power x less than or equal to e. So this is a simple one. And similarly, 0 less than or equal to x square less than or equal to 1. So in this case also, I'm going to get the same result. So 1 less than or equal to e power x square. So less than or equal to e. So also I can get it as 0 less than or equal to x e power x square less than or equal to e. So what happens over here? 2x e power x square less than or equal to 2e. So this will be equal to 2e. And if I'm just going to, this will be less than or equal to 1, again integrate. So I get again 2e over here. Okay. So it is going to be 2e. So your modulus in will be equal to, okay. So you have 1 by n common over there. So the modulus of e plus 1, so you get just e plus 1 over here. So here I have it as 1 by n. So it is e plus 1 plus 2e. So this is going to be 1 by n, it is 3e plus 1. Okay. So now, if I'm just going to look at the question over here, when your limit n tends to infinity. Okay. So limit n tends to infinity of this one. So your in value is this one. So what happens when your so modulus of in, it is going to be your 1 by n 3e plus 1. So what happens when the limit n tends to infinity of in? Obviously it will be equal to 0. So I like to tell one result that when it is going to be 0 to 1, and if you're going to have it as some f of x into e power sin, whatever might be, so it is a function over there. So in that case, you will be getting the resultant to be 0. So your f of x into sine. So whatever will be your f of x, but then it must be your x belongs to your 0, 1. So this value will be equal to 0. So kindly make a note of this result over here. So we'll move on to the next problem. So the problem is good over, and this one. So the largest positive number is such that your 0 to 5 f of x dx plus 0 to 3 f inverse of x dx is greater than or equal to a. So for every strictly increasing surjective continuous function, so it has been defined from f is equal to 0 to infinity again to 0 to infinity. So this is a problem that we are going to solve it. So this is also quite an interesting problem here. So the largest positive integer you are going to find. So it has to satisfy your 0 to 5 here and your f of x dx plus again your 0 to 3 and then your f inverse of x dx. So I just want to find what must be this a. So what is this actually? So this is nothing but your area between your y is equal to f of x and your x-axis, no? So where your x belongs to your 0 to 5. And this is the case, your area between, again your y is equal to f of x, but then with respect to your y-axis, your y belongs to 0 to 3. And look at the things that is given in your question. Your f is actually a function from 0 infinity to 0 infinity. It is continuous. It is surjective function. Definitely it must be an onto function over there. And also it is an increasing function. So many additional things it has been given. So it's strictly increasing, it is surjective, it is continuous. So many properties this function is having. So now, you just to see the thing over here. It's of 0, you have it as x and you have it as y. So you must have a function in such a way that, so definitely I can say your f of 0 must be equal to 0 because it is surjective, it is increasing also. Okay. So here we have a function of this form. Maybe have it as 5 here. So you might have it as 3 here. So it is 0 to 3, this one, and it is 0 to 5. Definitely this part. Okay, and this part. This is going to be your A1, this is going to be your A2. So now we are going to discuss in 3 cases, because what is the largest to 1? So what will be the cases that we are going to discuss is? So number 1, your f of 5 equal to 3. Your case 2, your f of 5 is greater than 3. And what is the next case is f of 5 is less than 3. In all the 3 cases, you're just going to find what? Because the largest positive integer. So this is what you're going to just check it with that. So let me take this to be my some h. Okay. So what is my h in these 2 cases? So what happens when my f of 5 is equal to 3? So 5, f of 5 and 3. Definitely this will be, my h will be equal to 5 into 3. This is equal to 15. So this is nothing but the area what I'm just computing as of now. If my f of 5 is greater than 3, so 5, it is greater than 3. So something. So above here I'll be getting it. Okay, this goes. So in this case also I'll be getting my 15. So what happens when f of 5 is less than 3? So f of 5 less than 3, we may just think that, okay, you may have something which is less. So 5. So maybe I have 3 here. So even when I'm just going to have it as 5, look at my y here, because the next one is 0 to 3, I just going to have. So in this case also, I'll be having, it will be greater than or equal to 15. So though I may have it as 14 or 13 or whatever it might be, the largest positive integer where it is being satisfying is actually 15 over here. Okay. So some questions are there for us to just have a logical thinking and go on with this. So another one interesting problem that it is a value of pi by 2. Okay, so this is also very interesting and easier one. So we have a similar fashion for this problem also. So what is the value of, so it is pi by 2. Okay. So we go with the value of pi by 2. So limit n tends to infinity. So I just take here in this case, it is cos pi by 4. So cos it is pi by 8. So it is cos pi by 2n plus 1. So now what will go this? Let me take my m to be, okay, this value. Pi by 2. So whatever we are just going to take, the same thing I'm going to take it as m. So let me take one substitution as, let my xn plus 1 is equal to cos of pi by 2 square, cos of 2 cube, it goes to cos of pi by 2n plus 1. So I just want to multiply this with, because it's only a simplification, the process, it is sine of pi 2n plus 1. So on both sides I do that. So this becomes cos pi by 2 square. This becomes cos pi by 2 cube. This becomes cos pi by 2n plus 1. And again, this becomes sine pi 2n plus 1. So now it comes like cos A and sine A. So you can have it as 2, because it is going to be in that case. In this case, I can have it as 1 by 2. So it is cos of pi by 2 square. This becomes cos pi by 2 cube. And this becomes 2 cos theta sine theta. No? So it becomes 2 cos 2n plus 1. And this becomes sine pi by 2n plus 1. So here it is 1 by 2. So you'll have it as cos 2 theta, no? You'll have it as here. So it is cos of pi by 2 square. This becomes cos pi by 2 cube. Sine 2 theta you'll be having it. So sine 2 pi by things. So 2 we can have it as pi by 2n. So you have another term. Definitely you will be having cos pi by 2n plus 1. The previous term will be definitely have it as cos pi by 2n. That would be the previous term. So again I want to multiply by 2 and divide by 2, so it becomes 2 square. Okay, so again it becomes 2n minus 1. So if I'm going to repeat the same fashion, so definitely I'll have the final term will be 1 by 2n. So now this becomes your xn plus 1 and this becomes your sine. It is pi by 2n plus 1 and this becomes your 1 by 2 to the power n. So now what happens? So what happens is here is your xn plus 1. So this will be again, so 1 by 2 to the power n. So I can bring this to the denominator part. It is sine pi by 2n plus 1. Okay. So what will be your L? So L is nothing but your pi by 2 into limit n tends to infinity of x plus 1. So you have it as your M as limit n tends to infinity. So pi by 2, you have it your xn plus 1. So that will be your thing here. So whatever we have taken, so that will be your M. So I can have this as pi by 2 is independent of your limit. So it becomes the limit n tends to infinity. So 1 by 2 to the power n. So here I can make one simplification. That is, I can have it as pi by 2n plus 1 into sine pi by 2n plus 1. So divided by again pi by 2n plus 1. So we know that. So limit n tends to infinity. Okay. So sine n by n. No? So you have it as equal to 1. So in that case, I have this value as pi by 2. Okay. So sine this becomes 1 and 2n this will be pi by 2. But then it is actually 1 by pi by 2. So this becomes pi by 2 into 2 by pi. So this becomes finally 1. So the value this becomes actually 1 over here. So we have the other problem. Yeah. So define S is equal to limit n tends to infinity. So 1 by 2 square.
Hello, Nivetha ma'am.
Yes, sir.
Yeah, our time is almost over. Okay, if you want, you can complete that problem and then we will go for an interaction with students.
Okay, sir. I shall. So maybe let me this be the last problem. So we can go on with this particular one. It is also very simple and quite interesting. But when we have a discussions of integral calculus here, so we are go on like this here. So now define this one and how to go on with the solutions. So here it is given that your S is equal to, so limit n tends to infinity. So it is 1 by 1 minus 2 square becomes 1 minus 1 by 3 square. And again it is 1 by 1 minus n square. So this is going to be a product. So we can take it as limit n tends to infinity. That's a product over here. So we take it as k equal to some 2 to n because the final term it is n. So I just take it as some k square. So you know very well limit n tends to infinity. So here product. So k is equal to 2 to n. I can have here as k square minus 1 by k square. So now it is very simple. Then you can go on like this. So limit n tends to infinity. So it is product k is equal to 2 to n. So it becomes k minus 1 into k plus 1. So I can have it as k and k. So once you start giving the values of your k, so your limit intends to infinity. So 2 minus 1, so it is 1 by 2. So 2, it is again 3 by 2. We put k is equal to 3 over here again for the next term. This becomes 2 by 3. So this becomes 4 by 3. So as you see, what will be the final one? So you have it as n minus 1 by n and n plus 1 by n. Okay, this is a last term. If it is going to be n minus 1, so this is going to be n minus 2 by n minus 1. So n minus 1 plus 4, so it is n by n minus 1. So all the terms, it goes off, and what will be left out with? So limit n tends to infinity 1 by 2. We will left out with n plus 1 by n. So when n tends to infinity, take n outside, then finally it will be 1 by 2. So with this, I just wind up the things. So a few more problems are there under 2020. So maybe if I get another time, I can share those problems and few additional problems. So what I felt that when I'm solving and taking the problems, that everything it is having the touch of analysis in one or other way that. And even few problems we can say that it may mislead us. Okay, there's something else is not an integral calculus problem. So I have a problem of that kind. So I was not able to go on with that. Maybe the next time, if time permits, I can get back to you of those questions that which has a touch of the analysis part, and it may mislead us. No, this is not a part of integral calculus. So I thank you, sir, for the given opportunity. And since now it is time for the discussions, yeah.
Okay, thank you, Nivetha, for being with us and for this interesting session on integral calculus. Now it is a time for interaction with students. Yes, dear students, please come forward and share your comments. Yes, Alina.
Hello, ma'am. My name is Alina Anna Matthews. I study in Marthoma College, Chungatra, third year student. Thank you, ma'am, for taking so much effort and time in taking such a class for us. I'll also like to thank Vinod sir for organizing such a class for us. Ma'am, could you suggest some books for integral calculus?
Books in the sense, actually there are special books are there for you to go for practices. But what I like to say is there are so many video lectures other people are regularly posting over here. But what the calculus that the students, what we are teaching, they are very much preliminary only actually. But the questions that's been asked in like IIT JAM or something else, it is something more that make you to think over it. So I like to just go on with you. If at all, if you're able to cope up with some few NPTEL courses, that will be very much fine, and you can go on with it because so much initiative that people are going on with that. So there are problems, so that some courses are like that. So you can take up such courses, and it will be an enlightening session for you because it has been taken up by all IIT professors. So their viewpoint and their perspective or something, it may be good for us also when preparing for these exams.
Okay, ma'am. Thank you.
Okay, thank you, Alina. Others?
Hello, sir.
Yes. Yes, Gopika.
Hi, ma'am. Am I audible?
Yes,
Hi.
yes.
Hi, ma'am. I'm Gopika from Guriyarpet College, Kozhikode. I'm third year BS Math student. Thank you, ma'am, for this session. Today's session is really nice. It's helping us for our gym, and you discuss the theory part along with the problems. It's helping us to understand easily. Thank you, ma'am, for spending your valuable time with us. And thank you, sir, conducting this session for us. Thank you.
Okay, thank you, Gopika. Others?
Hello, ma'am.
Yes, Gayatri.
I'm Gayatri. I have studied in Miranda House College, Delhi. I couldn't attend the previous class, but I saw the recorded video. Since then, I was waiting for more classes from you, ma'am. And you have taken a wonderful class. And it was really useful that you have discussed the problems that came for the JAM exam. I hope we will get more classes from you, ma'am. Thank you.
Thank
Sure.
you, Gayatri. Thank you. This is
Good
Russia.
afternoon, ma'am.
Hello.
Myself Shilpa.
Yes, Shilpa, please wait. Russia, please continue, Russia.
My name is Rasha Ved, and I'm coming from Krishnamiran College from Kannur. Today, thank you so much, ma'am, for today's class, and I'm very grateful for being in ma'am's class today here, especially because I could easily grasp the concepts and each point was said, since each and every point was said, I could get the flow very easily. So, and since this is a topic that I really like, so I found it very interesting. So thank you so much, ma'am.
Okay, thank you, Russia. Okay, Shilpa, yes.
Ma'am, myself Shilpa. Now I'm a graduated student from SN College, Kannur, currently focusing on my jam preparation. Actually, today's topic was very interesting for me also. Differential calculus and integral calculus are one of the branches that I love to study in maths. And you have invested your valuable times for us to conduct such a nice class. You were explaining everything step by step, which was very easy for all of us to grasp. So, ma'am, thank you for this wonderful interactive session. Thank you, sir, for organizing such a program.
Okay, thank you. So, Nivetha,
Hi, ma'am.
Yes, Abhan.
Hi, ma'am. My name is Aparna Lal. I'm also a graduated student from NSS College near Anandar. Ma'am, today's session, I was there from the starting to the end, and it was a really good way you taught us. Like I could even when I first saw the questions, I was like, oh my god, how will we get the answer or how I have to do it. Even I tried to do some of the questions with you, but I got stuck in halfway. But when you gave us like these are the things, these are the ways to solve it, and I was like, yeah, I have to think about it and I have to study so much, like I have to grasp all these concepts. And so ma'am, thank you so much, and if you have time, please spare some time for us for next session also. Thank you so much, ma'am.
Thank you, Aparna. Atas,
Good evening.
yes, Alina.
Myself, Halina Binu from St. Dominic's College, Kandirapalli. Thank you, ma'am, for this wonderful section. When I see the first question, I think, oh my God, how will I solve this? I didn't even understand the meaning when I read first, but when you give the solution, oh, we can think such a way also this problem. Thank you, ma'am, for your wonderful section. Thank you.
Thank you, Alina.
Hello,
Yes,
ma'am.
yes, Malavika.
I'm Malavika, third year BSc Math student of 𝕨𝕚𝕥𝕙 Guruvayurappan College. Thank you, ma'am, for this wonderful session. It is really helpful for us and we really enjoyed it. Thank you so much for your time and effort. I would also like to thank Vinod sir for conducting such a wonderful session for us. Thank you, ma'am and sir.
Thank you, Malavika. Yes, thank you. So,
Sir,
yes,
ma'am, I am Anamika from Zamni's Guruvayurappan College, the second college of Malavika. And thank you, ma'am, for this nice session. We enjoyed this session well, and you discussed different kinds of problems that help us to know more about the questions and different questions. As everybody said, the questions are really great questions. We initially we thought that it will be difficult for us to understand, but you experience each step, and it help us very much. And thank you, ma'am, for this your effort and your spending you spend your valuable time with us. Thank you, ma'am, and thank you, sir, for this nice session.
okay, thank you, Anamika. I think almost all the students have expressed their views. So, Nivetha, I'm very happy that all of our students are really happy with your class. So, and they are they are eagerly waiting for further sessions from your side, so we can think about such sessions in future. And also, Nivetha, please share the notes of these classes. We can share it with our students. That may be very helpful for them in their preparations.
Okay, sir.
Okay, let us wind up the session here. Thanks, everyone. Thank you.
Thank you, sir. Thank you for the given opportunity. Thank you all, sir. Thank you.
Okay, thank you.